Almost done with this section, but it's a very important section, a bit lengthy. If I say differentiate on number 62 just as is, I could say y prime equal the quotient rule. Derivative of the top, that's the product rule. 4 into x plus 1 cubed times x minus 5 cubed plus x plus 1 to the 4th times 3 into x minus 5 squared, derivative of the top times the denominator. So, derivative of the top times the bottom minus the top times derivative of the denominator, which is 8 times x minus 3 to the 7, all over the bottom squared. A lot of fun if you ask me. But if you look at the directions, even if they didn't ask us on the directions, I could add logs. Logs are going to make life a lot easier on those two problems. And let me demonstrate really quick. That is, if I take natural log of both sides, I could say natural log of y is, this is going to be 4, you know what, I'll do it in 2 steps so you guys don't get lost. This is going to be natural log of x plus 1 to the 4th plus natural log of x minus 5 cubed minus natural log of x minus 3 to the 8. Not only that, I'm going to take this even a step further. I love it when it does that. I'm going to take it a step further and say natural log of y is actually 4 times natural log of x plus 1 plus 3 times natural log of x minus 5 minus 8 natural log of x minus 3. And when I take a derivative, I'm going to say 1 over y times y prime by implicit differentiation. 4 times 1 over x plus 1 plus 3 times over x minus 5 minus 8 times 1 over x minus 3. And I'm going to say y prime equals, and there it is. If you multiply by y both sides, wouldn't y equal the initial? Isn't that x plus 1 to the 4th, x minus 5 cubed over x minus 3 to the 8? And that would be my answer. So, there it is. Now, I could jump straight to saying, you know what, I'm going to take natural log of both sides, and this is going to be natural log of y equal 4 times natural log of x cubed plus 1 plus twice natural log of the sine of x minus 1/3 natural log of x. So I could do that from the beginning. And I could say, if I take a derivative, 1 over y prime is going to equal 4 times 1 over x cubed plus 1 times 3x squared plus 2 times 1 over the sine of x times the derivative of sine, which is cosine, minus 1/3 times 1 over x. And I could say with ease that, you know what, y prime is going to equal y times 12x squared over x cubed plus 1. You know what? it would fit perfect and look a lot nicer if I was to do it this way. I could say y prime is y times 12x squared over x cubed plus 1 plus twice the cotangent of x minus 1 over 3x, and I could say y prime is, put y back in, and there it is. And of course you could leave the answer like that on the test or even on the homework. The author does that as well. They're showing you that logs allow you to solve extremely complex problems. We don't go in depth in those. And y was actually the initial problem. That's x cubed plus 1 to the 4th sine squared of x over x to the 1/5. Now, the last aspect of this section, the good news, you know about one technique of an equation. You're going to learn 4 more. Evaluate the integral. You are aware of u sub. If you let u equal 5x plus 1, the denominator of a fraction, the inside of a radical, the power of an exponential, right? Du will be 5 dx. So this becomes the integral, and let's see how this works. This right here is my u. And dx is really a du with a 1/5. Now your teacher might have shown you a trick to transform the limits on the integral, maybe not. That's why I'm doing that. I want to show you something and you should be doing that. This is 1/5. What do you take a derivative of to get 1 over u? Natural log of absolute value of u. And wouldn't that be 1/5 natural log? And what was u? U was 5x plus 1 evaluated from 0 to 3. That is 1/5 times, throw the 3 in, that's natural log of 16. Put the 0 in, natural log of 0. And of course, a natural log of 1, natural log of 0 is undefined. What am I thinking? Well, we know what I'm thinking. That right there is a 0. Now, something I need you to start doing. If you're not used to this, start getting used to it. I will proceed the same way. I will say let u equal 5x plus 1. So, but I want you to lean more this. If your previous math teacher didn't show you that, here it is. This is the integral. This is my u. And dx is really du with a 1/5. Since this is a dx, this is x equal to x equal. If x equals 0, put a 0 in there, that's going to be a 1. And if x equals 3, 15 plus 1 is 16. You're getting those evaluations right there before. That will save you time on the long run in this class. This is natural log of absolute value of u. Now, I don't need to go back to x. You can only do that if you have a definite integral. If you've forgotten what definite integral is, when you have limits, you can't do that on this problem because this is not a definite integral. And this is going to be 1/5. Throw the 16 in. Throw the 1 in. Of course, that's a 0. So that's 1/5 natural log of 16. And if I look at the last problem, again, what do you let u equal? You let u equal the denominator of a fraction, the argument of a trig function. So far, glancing at this, this looks like the integral. The cosine I didn't touch. It seems I replaced natural log with a u. What is du? 1 over t dt. Do you see that this right here is this right here? And what is that? What do you take a derivative of to get cosine? Sine of u plus c. Unlike the previous problem, I must go back to t because this is not a definite integral. What was u? U was, and there it is. And the homework on this section is right there. Oops, I'm missing a part. Let me fix it. There's the homework. 6.2 star. Again, make sure you're on the right page, page 445. Number 1 through 41 odd. Number 47 through 75 odd. Skip 53, 55, and 59.